Well, hello there. So in this video, we're actually going to need a calculator here. So let's pull that up, and we'll hopefully we'll make kind of quick work with it. This is module 11, which is an extension on GDP, and so we're going to be doing a lot of nominal and real and adjusting for prices and so forth. So check your understanding. Number 1 has a couple of different parts to it, and it says assume there's only 2 goods in the economy: fries and onion rings. In 2009, this was the price, and this was the quantity, and then 2010, this is the price and the quantity. Calculate nominal GDP in 2009, and then calculate and in 2010, and then calculate real GDP in 2009 using 2010 using 2009 prices. So let's kind of break this up into little parts here. Let's start with GDPN nominal in 2009. So for this one, we're just going to need the price and the quantity of the stuff from 2009. It's the simplest one. So we had 1 million servings of fries, 1 million times 40 cents. Plus the 800,000 onion rings and 60 cents. So 800,000 times 60 cents. So let's do that. 1 million times 0.4, we should know is 400,000. And 800,000 times 0.6 is 480. So this is 400,000 plus 480,000 equals 880,000. Now we're going to do GDP in 2010. And this one, we just use 2010's quantities, 2010's prices. So we're kind of repeating the process. In 2010, the price of fries was 50 cents and servings was 900,000. So 900,000 times 50 cents plus onion rings were 51 cents and they sold 840,000. These are oddly specific numbers, so probably the math is going to be really hard. 900,000 times 0.5, we already know, 450,000, plus 840,000 times 0.51, 400, what a stupid number. God, that is dumb. So that's 878,400. Why would they do that? That's dumb. I hate it when textbooks do that stuff. And then we need real GDP in 2010. GDPR 2010 using 2009 as the baseline. So we're going to use 2010's output, which we already have written up here. We have 900,000 times, and then we're going to add the 840,000 times. And so what we're going to multiply it by is the 2009 prices, which we have up here as 0.4 and 0.6. So then we have 900,000 times 0.4 is 360,000 plus 840,000 times 0.6, 504,000. Down. 864,000. I think it's dumb. Like, what was the point of all that math? Nothing. It's dumb. Computations. And then for part B, it says, why would an assessment of growth using nominal GDP be misguided? Well, because nominal GDP can be affected, and it is affected by price level changes. So like you could end up with a really big increase in nominal GDP, but it's only because the prices went up a lot. It had nothing to do with that you were making more stuff. Okay, number 2 is a dumb question. So I'm going to put an X on it. I just think it's dumb and I don't like it. It's a dumb question. You don't have to do that. Multiple choice, number 1. It's always nice when the teacher's like, you know what, that's dumb. Don't do that. Which of the following is true of real GDP? It is adjusted for changes in prices. Yes. It is always equal to nominal. No, it's almost never. It's only equal in the base year when you're using the same year's price. Like if you're saying, what's the real GDP for 2020 and using base year 2020? Well, then it's the same as the nominal, but that's the only time. It increases whenever aggregate output increases. Well, that is true because it's not affected by prices. It's just the output. So 1 and 3 is D. Number 2, Best measure for comparing a country's aggregate output over time is real GDP, so B. Now, I do sometimes have students who argue that D is a better answer here, but this is aggregate output. It's not like comparing standard of living. It's saying the total amount of output, and that's not adjusted for population. It's just saying the total amount. So B is the better answer here. Number 3, use the information in the table for an economy that makes apples and oranges. Assume year 1's the base year. Okay, this is going to be more math, I can tell. What's the value of real GDP, got a little bigger, in each year? Year 1, year 2. So we just have to calculate real GDP. That's actually not that bad. So real GDP in each year using year 1. So for this, we'll just say GDP R in year 1. And so in year 1, they had 3,000 apples times 0.2 plus they had 2,000, whatever those are, times 0.4 oranges. And so 1/5 of 3,000 is 600 plus 2/5 of 2,000 is 800. So that's 1,400. And now we need GDPR in year 2. And that's using year 2's quantities, 4,000 times the original year's prices, so times the 0.2, plus 3,000 times 0.4. And again, I'm using year 1's prices, so I'm just bringing them down. So 1/5 of 4,000 is 800. Fractions, kids. And then 2/5 of 3,000 is 1,200 equals 2,000. So 1,400 and 2,000 are C. There you go, C. Number 4. Real GDP per capita is an imperfect measure of the quality of life in part because it includes the value of leisure time. No, it doesn't. So that's not it. Excludes expenditures on, no, it doesn't do that. It includes those. C, includes expenditures on natural, it does do that, and that does bring your quality of life down. So I'm going to probably guess C, but let's look for the others. Excludes expenditures on entertainment. Well, that's not true. It includes those. Includes the value of homework. Well, it does not include the value of homework, so we can rule that one out. So C is the best answer here, 5. Refer to the 2009 data. Nominal GDP in billions of dollars. Which of the following must be true? Residents of Japan were worse off than residents of the US or the European Union. Well, this is just the total GDP. We don't know what the population is. So we can say we don't know that number 1 is true. Number 2, the EU had a higher nominal GDP per capita than the United States. Again, we don't know how many people live there, so we can rule out number 2. 3, the EU had a larger economy. That we can look at it and go 16 is bigger than 14. So that is true. 3, only C. And now, last but not least, free response number 2. Use the information below to answer the following questions. Now, I will just say if you're using the paper book, that it's a very similar question, but actually I think it's a little bit easier than this version, but they're basically asking you to do the same tasks. So first it says calculate % increase in nominal GDP between 2005 and 2010 for each country. So part A, and if we just remember, % increase is % change is new minus the old over the old, and that's all it is. Times 100. So that's kind of telling us our % changes. So if we're looking at prices, right, % increase in nominal GDP went from 2 to 4. So that's for A, it's a 100% increase. For B, nominal GDP went from 2 to 6. So that's a 200% increase. Okay. B says what happened to the price level in each country between 2005 and 2010. So for A, there was no change. You can see it stayed the same. For B, it went from 100 to 200, so that's a 100% increase. And then C says calculate real GDP in 2010 using 2005 as the base year. This one's actually a little tricky to do. So C, for this one, real GDP in each country in 2010. So in order to know that, we have to figure out how much output they had and then multiply it by the price in the original year, right? So we have to figure out the amount of output, and that one's kind of tricky. Now, for country A, because they didn't have a price level change, we actually know that the nominal is the same as the real for both years because the price level stayed the same. So we actually can kind of just cheat and say 4,000 because they give us the nominal GDP for that year. For B, though, it's going to be trickier. So first, we're going to figure out how much stuff did B make in the year 2010. So we'd say in 2010, we know they made $2,000 worth of GDPN, and then we'd say divide that by the price level, right, which is 200, and that, right, that tells us how much stuff we made. So we made 30, whatever this thing is. And then we could multiply it, right? Price level in 2010. So this is the output, and I'm going to call it Y in 2010. Now we multiply the 30 units of whatever this is times the price in the original year. And the price in the original year is given to us as 100. So 30Y times $100 is equal to $3,000. So that's how we figure out what's the real GDPR in 2010. Now it says calculate the percent increase in real GDP between 2005 and 2010 for each country. Well, for country A, we are running low on space. The percent increase, it went from 2 to 4, but the nominals are the real, right? Remember, for country A, their price level didn't change, so we don't care. So for them, we'd say a 100% increase. For country B, it went from originally $2,000 to $3,000. So 2,000 to 3,000 is a 50% increase, excuse me. And then E says compare the two countries' real GDP per capita in 2010, 2005. Oh my gosh. So real GDP per capita, oh my gosh, this is a pain in the butt, isn't it? We're just dividing by the population. And so we would say the real GDP for A in 2005, real GDP per capita was 200. And A in 2010 is 4,000 divided by 20. 4,000 over 20 is 200. So it stayed the same. Okay, that makes sense. All right. And then for B, 2005, it was the $2,000 divided by 10, so it's 200. B in 2010 is this $3,000 divided by 15, which is 200. So neither country saw any increase in real GDP per capita. So all of the increase that we would say in terms of like their output level was due to either population or price levels. Well, we did all that math to learn that. Cool. Thanks a bunch. See you next time.